Well, good afternoon, everyone. Happy Friday. Thank you for joining us for yet another great webinar here. This is something we're especially excited about. The Octopus Track is truly unique out there in the marketplace. And leading this, we've got Nathan Massey, channel manager for B&R. Going to go ahead and go through this. If anyone has questions, feel free to jump in via chat or speak up if you need to as well. And forward to a great session.
Yep. Thank you. Thanks, Chris. So yeah, thanks everybody for joining. My name's Nathan Massey. I'm the regional manager for B&R, and I cover the Northeast region of the United States. And so I'm here in Roswell, Georgia. And so I wanted to kind of go full screen for a minute because I wanted to be able to show you where I am. I'm sitting in our digital innovation space here in our Roswell office. So you can see behind me some of our demos that relate to some of the topics we're going to talk about today. And I'm hoping that at the end we'll have a few minutes and I'll actually pick up the webcam and give you a quick tour back there as well. But let me jump back into the slide here. The topic that we want to talk about today is track technology. So track, when we talk about track, it's the flexible transport system that enables adaptive manufacturing and more efficient production. And I'll explain a little bit more about what that actually means over the next few slides. So maybe first of all, some of you may have seen B&R Track before, some of you may not have. So maybe to start with, let me just play a quick video here. I've turned the audio off. But I wanted you to at least visualize what we're talking about today. Some of you may have seen it at a trade show. Some of our customers are already using this technology. They're already exhibiting it at shows and shipping it on machines. But what we're looking at on the video is our Octopus Track, which is one of our track technologies that we're going to talk about today. Good. So I'm not going to let the whole video play through, but I just wanted to kind of share that quickly. There's really two different products that we have that utilize B&R's track technology. So Super Track is kind of the big brother of the Octopus Track. So Super Track is in its third generation. It has more than 15 years in production, higher payloads, higher precision. Octopus Track is based on that same technology. It's more dynamic, more flexible. It's also the world's first and only track system with HighSpeed Diverters. And most of what we're going to talk about today really applies to both track technologies. But we are going to kind of focus a little bit more on the Octopus Track. So I just kind of wanted to share that as well before we get started. And so what is the goal of today? So every time I've done these track presentations, typically what happens is it leads into some discussion, some whiteboarding, some different ideas. The engineers and salespeople will start scratching their heads and saying, well, could we do this? What about that application? What about that issue we've been having? And it's different every single time. And we get into these discussions. And I think this format that we have now, this virtual format, doesn't quite lend itself as well to that. So if you've got any ideas that pop up, maybe this could be interesting, or would it even apply to this? Pop a question into the chat and let's talk about it. Or just let me know, hey, Nathan, hey, Chris, reach out to me tomorrow, Monday, whenever, and let's just chat about something. I want to know if it would even work for what I'm doing. And so let's do that. Let's kind of have that virtual whiteboard discussion. So with that being said, let me keep moving forward. So what are the basics of track? So Octopus Track, it's a transport system based on long stator linear motor technology. So it's really the same technology that's in a standard servo motor. But we've opened up that circular shape of a servo motor and made it into a linear motor, a linear actuator. And with that, we have complete freedom over the track layout and the track design. And each shuttle is equipped with permanent magnets. And really those permanent magnets on the shuttle correspond to the rotor that would be inside a conventional servo motor. And with that technology, the Octopus Track can control each shuttle on the track individually. Each shuttle is equipped with permanent magnets, and the permanent magnets are what actually holds the shuttle to the track. And then along the track, which is the stator in the servo motor example that we're using, along the track, it consists of a series of coils. And as we apply current to those coils, we can apply forward and backwards motion to the permanent magnet of the shuttle. So with that, we can control every single shuttle individually. So what are some key features we can achieve with that very basic overview I just gave? Number one is independently controlled shuttles. So we can control each shuttle independently, which means we can control each product or each group of products independently, and we can control the pitch between each product independently. So now your conveyance is completely flexible and can match exactly what type of production or what type of process you have. It also means we can now adjust production to any batch size, even down to batch size 1. Number two is the flexibility of the track design. So with just a few basic shapes of the Octopus Track, we can really create some very flexible and very customizable layouts. So what it really means is that the Octopus Track or the track technology can meet the needs of your process and your production, as opposed to the process having to fit the conveyors, or the other material handling technology. We can have more than 100 meters of track length and more than 250 shuttles in a single system. So really a lot of flexibility and a lot of expandability there. I already mentioned the HighSpeed Diverters. So Octopus Track is the only system in the world that allows high-speed, full-speed diverters, which makes it possible to divide and merge products at full production speeds. The way that's done, we have permanent magnets on both sides of the shuttle. So by doing field weakening on one side and field strengthening on the other, we can cause the shuttle to move from one track to another. And we can do that at full speed. And so because there's no mechanical components doing that merge or that divert, there's no additional wear or maintenance to do this divert. Next is hot swappable shuttles. So this is another unique feature. Shuttles can be swapped out from the track on the fly during production, even while the track is powered up. The shuttles are only held onto the track by the permanent magnets, so they can easily be removed and replaced in a matter of seconds. And actually the demo behind me that we're going to take a look at the end, we're actually using the robot to add and subtract shuttles on the fly while it's running. So with that, it's possible to create, for example, pit lanes where you can change out the shuttles or change out the tooling on the shuttles during production while the rest of the system is running at full speed and full production. So you can have some very short changeover times from one product to the next. Maximum productivity because of the speed and the pitch of the shuttles. So the Octopus Track can travel up to 4 meters per second and has an acceleration up to 5 Gs. And you can fit each shuttle, meaning each product, in as small as 50 millimeters. So you can get the maximum amount of production in the minimum amount of space at the maximum speeds and accelerations that you need. There's also a common DC bus, so energy can be shared between different shuttles and different parts of the track. So if you've got certain parts of the track where you're decelerating heavy inertias, that power can be shared with other parts of the track where you're doing the acceleration. Also, the track can be oriented in different formats. It can be horizontal, like the picture we saw before. It can also be turned vertically. And we have a demo behind me that we're going to take a look at as well. Precision. So our B&R's track technology has a repeat precision down to 10 microns. So you can really do some high precision activities. So in this example here, we're actually seeing a robot that's coordinating motion with the track. You can see in the shuttle, there's actually a hole, a pattern cut in the shuttle, and the robot is moving with the shuttle and matching that pattern and shining a laser down onto the floor below while it's in motion. This is also showing that we can utilize the corners of the track as well. So this is another space-saving feature. You can do production, filling, capping, labeling, whatever it is, on the corners of the track, not just on the straightaways. The Octopus Track is inherently washdown. It's IP65 washdown rated. And we also offer an IP69K variant with an even higher rating. So it's the IP69K is rated for high pressure, steam, jet cleaning up to 80 degrees C. So you can really use the track as part of hygienic designs in pharmaceutical and food and beverage applications. Another very important thing about the track is the software behind the track itself. And there's really three key things there. Number one is the process-oriented programming, integrated collision avoidance, and the digital twin simulation. So what do I mean by process-oriented programming? What you don't have to do is define the motion profile for each shuttle individually and control that motion and command each shuttle where to go, when to stop, where to wait. You simply program in process points. Here's where we're filling, here's where we're capping, here's where we're labeling. And you simply tell the shuttle, okay, your filling is done, go to the capping station, and all of the motion is handled for you. And with that, the collision avoidance is handled as well. This would be another very complicated thing to program yourself, especially on very large, high-speed tracks. That is automatically built into the firmware to do the collision avoidance. And then finally, the digital twin. So it's very easy to simulate the entire track, including the other processes that are in the track, either in a 2D or 3D format. And what's great about it is once you've designed your simulation, once you've proved out the concept, that same code, that same configuration that you created can then be used to run your actual machine in the field. So you can really design the system and test the system before the first piece of hardware even shows up. So now let's talk about some ways we can apply this technology. But we've got a lot to cover in a few minutes here. So let's talk about how we can take some of those benefits and really apply it. So the first one is merging product flows. So with Track, we can divide and merge products in various ways. So here we're seeing an example where maybe we have 3 different products, or maybe we have 3 different manufacturing processes that we're doing, but then we need to combine those into maybe a rainbow pack. And so we want to customize every single package, every single box, every single output to be exactly what the customer has requested. And we can do this by using the merging product flows. Next, dividing product flows. So examples where you might use this might be if certain products need additional processing, or if we want to detect problems or rejects and send those off or send them back to be reworked. So here in this video, we're seeing products come by a camera. So we could have an integrated vision system here, and we could be looking for fill levels. Is the cap on right? Is the label on right? And then we could send any of the problem products off to a separate area. And so now they're no longer taking up space in our conveyor, in our feed screws. We're not having to send it down and waste additional caps and labels on product that we already know is bad. So another example of using the track would be for improved fault tolerance. So let's say part of our process, we're doing capping here in this example. Let's say one of our capping station goes down. So in a typical application, typical conveyance, like a feed screw, for example, you would continue to have to put a bottle in every capping station. So we'd still be wasting a bottle, wasting a cap, wasting a label. Here, as you saw in the example, we were able to simply bypass one or more stations while still filling the rest of the stations on the fly. So we don't have to shut down our full production line. We can continue to run at a lower rate while we fix the issue. Next, we have parallel processing. So oftentimes in a manufacturing process, different parts of the process take different amounts of time. So in this example here, we're seeing maybe a soldering station that takes longer to execute. So on the left side of the screen, those 3 stations can be run in parallel while all of the other stations are run one up. So we have a 3-up station and then everything else is run 1 up, and we're really able to maximize the productivity of the entire production line. Another example is scalable machinery. A lot of times end users face the challenge that once they've invested in large capital equipment, in the future, if they need to make changes, if they need to expand the equipment, if they need to add additional processes, it's very difficult. And oftentimes it means scrapping the old equipment and buying brand new equipment. But with Octopus Track, it can easily be added onto and expanded later in the field in the future. So you have that flexibility to continue to expand it as the production line grows. Another example is interlinking with conveyors. So some systems only need the high performance and synchronization during a certain portion of the process. And the rest of the process might be perfectly fine with conventional conveyor. So here we're going to see a video, an example where we have conventional conveyor bringing product in, but then for a certain portion of the production, we need the flexibility of track technology. But then once we're done with that processing, we can go back to conventional conveyor. So now we get the benefit of track with the cost effectiveness of conventional conveyance. And no special hardware or additional equipment is needed for that handoff from one to the other. We can also integrate CNC and robotics with track. So for example, here we have what could be a gluing station or a laser cutting station or a printing station where we're actually coordinating the motion of the track with the CNC process that's being executed on it. So now we're actually eliminating one of our axes of the CNC process. And then here's another example where we're integrating with robots. So we've got a robot that's picking up a part or executing some process on a part while the track is in motion. So good. So I know I kind of ran through a whole lot very quickly there. We talked about a bunch of different ways it can be applied. We talked about all the different features. I've got a couple videos I'd like to show you next, but I wanted to share this quote first. So this is a quote from Keith Jacobs. So I don't know if you're familiar with who he is. He's actually the inventor of another track technology, iTrack. And he made this announcement after the SPS show in 2017. He said, B&R's announcement yesterday of the new Octopus Track represents the second generation of independent mover technologies because it's brought together several elements that those of us who pioneered the technology dreamed about years ago. And so I think that's a really powerful statement. So we've got a couple videos that I'd like to show you, and we've got a lot more videos on YouTube as well. So I just selected two of them. This is a company, Macro Labeling. They're using the Octopus Track for a very high performance labeling application. And in this example, they actually have multiple tracks. They have one track on the top, as you can see there, and they have a second track on the bottom supporting the bottle. And they've actually done something really cool. They're using two shuttles together with kind of a rack and pinion mechanic to it. So by moving the two shuttles closer or further apart, they can actually twist or rotate the bottle during the labeling process. So this would be considered definitely a very high performance labeling application, but it's really cool how they were able to apply multiple tracks together to give that control over the rotation of the bottle. Here's another example. This is raunchy. This is a bottle unscrambling machine. They're utilizing Octopus Track along with ABB Delta robots, flex pickers. So this is completely controlled by B&R along with the ABB robots. So what they're doing is they're feeding in bottles. They have a vision system that's looking at the position of the bottles, and then they're using the robots to pick up the bottles and orient them in the right fashion for the next step in the process. You can see that there's two shuttles being used together to grip a bottle. What's really important about that is it allows them to change from different size bottles and different shape bottles on the fly without any changeover. So you're going to see it slow down here in a minute, and you're going to see two shuttles that are going to come together and pinch a bottle once the robot hands off the bottle to them. We also saw that we can do on the fly swapping of the shuttles as well. So here you go. The robots are feeding into the Octopus Track. You can see it slow down here in slow motion, and it's going to put the bottles in, and then by the shuttles pinching together, they're able to grab different size containers. So next we're going to see this change on the fly. The operator is going to go to the menu here in a minute, and they're going to tell the machine that they want to do a different type of bottle, a different size bottle, and we're going to see it change on the fly. Another cool thing about this example is they've actually mounted the track on a 45-degree angle. I don't know if you noticed that in the video, but in order to handle their process, they wanted it at a 45-degree angle, which of course is possible with the track. So now the operator has commanded a changeover. It's emptying out all the old bottles. Then they'll start up the new production, and we'll see a new size, a new shape bottle start coming in. And just by changing the pitch between the shuttles, we're going to start processing the new bottle shape. Good. So yeah, I know I kind of ran through a lot right there. Maybe I'll pause for a minute and see if we have any questions or comments or any ideas anybody would like to share.
I think that was really interesting, Nathan. It's cool to see the actual real life applications in there as well as the simulations. So,
yep. Yeah, and maybe to add to that, we've got I mentioned we have quite a few videos on our YouTube site. I would highly recommend it. There's a lot of our customers, the way they design their machines is very much part of their intellectual properties. So not all of our customers want to share that information, but we do have quite a few customers that have already done YouTube videos of their track technology. You can find those on the B&R page. We've already got a number of US customers as well that have been willing to share their technology. They've exhibited them at some of the trade shows, and we've been able to do joint videos with them. So I'd invite you to take a look at that. what I'd like to do is maybe pick up the camera and take you back to the space quickly and just show you one of the demos that we have running. So if you'll bear with me for just a minute. So you should be able to see the innovation space back behind me. Hopefully the audio is okay. It is a little bit noisy back there, but we'll see how it goes. So we're just going to walk back here quickly. All right. So before we jump over to this guy, we've got one of our super tracks right here. So this is our super track with multiple robots connected to it. You can see this guy's fired up. So in this demo, we have two tracks. We've got an integrated camera, and we've got an ABB robot. So right now, they're just kind of cycling, but in a few minutes, we'll actually see the robot select certain color balls and pick them out. And so we're using this camera. This is a B&R camera. It's integrated into the rest of the system. It's actually checking what color ball is on the shuttle, and then that'll help the robot determine which shuttles it wants to pull out. What we're also showing here is our digital twin. So we're actually running a live simulation of a digital twin at the same time as the actual demo is running. So this would be an example of how you could design the system in software, in the simulation, without even having any of the hardware yet. We've got another demo over here. This one's turned off at the moment, but this is our vertical high dynamic demo. So it's basically the same track that we saw over here, just turned 90 degrees. This allows us to either hold product on top of it or hold product down below. So for example, a bagging machine, you might be suspending a bag below the track, and two of the shuttles might grab each corner of the bag. Here we've got one of our training setups. We can invite customers to come in here and do trainings on track alignment, track buildup. And then finally, behind this cage, this is our test area. This is where we can actually take customer applications, bring them here, and work alongside the customer developing new technology. We also have the ability to put up curtains around this if there's any technology the customer wants to keep private. Some of our customers, for example, have special tooling that they use on the track to support their product, and they want to keep that information confidential. This is where we'd work on that together with them. All right, well, thanks for bearing with me. I know it was a little bit noisy out there, but yeah, thanks for joining me today. And Chris, I guess I'll hand it back over to you.